Ladies and gentlemen, it is lesson 2, and we're going to talk about limits today. Little review of the derivative, and then we're going to talk about the limit definition of the derivative. But as we begin, let's talk a little bit about the history going to limits. So as you know, Newton and Leibniz, which we've talked about before, around the 17th century, both contributed to the invention of calculus. However, limits was not first introduced at that time period, although maybe the phrase was coined during that time period. It certainly was not the first time a mathematician had thought of the concept of limits. Archimedes, circa 200 BCs, actually touched on limits when he was looking to calculate the area of a circle. And his process was to consider a polygon inside a circle. So a polygon inscribed in a circle, such as you see here. And what he realized was, if you increased how many sides of that polygon, you would decrease this area that I'm coloring in purple, thus getting closer and closer to the true area of a circle. And this would be a less formal but clear application of thinking along the terms of a limit. As n increases or goes to infinity, in this scenario, we get closer and closer to the true area of a circle, because you could calculate the area of a polygon with those number of sides. Now, moving on to Newton and Leibniz, of course, we formalized it just a little bit more, and they invented this conversation of limits. And I say conversation because it still lacked a little bit of structure as to what a limit formally should be, and it was more talking about approaching values, or as you guys saw yesterday, the limit as x approaches c of a function gets you to some point in the y value. So, in the picture that you see here, whether you're traveling from the left or traveling from the right, this limit exists because it approaches a height of 2 from either direction. And therefore, the limit as x approaches c of f of x would equal 2, even though the function value, f of 2, is clearly not, f of c, is clearly not the same value. So, a few years later, we're talking many few years later, in the early to mid 1800s, we've got Cauchy, who formalized this definition of a limit. And in this case, he actually looked at almost like tolerance. How close are you getting to c, given that the gap could be plus or minus a value called delta. So the closer we get to c, right, the more that could affect the output as we get to L, the limit. So in this definition, much more formal, it talks about how close you get to the value that you're trying to reach and how that has an effect on the tolerance or the outcome of how close you get to the output or that limit. So you can plug in that tolerance into your function, and then you get a variable outcome with your limit. This is similar to the idea of creating certain models of different screws that would match up with different types of bolts. Meaning, as long as the screws have a certain distance between each thread, the distance here, then it's within a certain tolerance to fit a specific bolt. So when you are manufacturing screws and bolts, they give an allowable tolerance for each type of standard so that screws and bolts can all be a universal thing when dealing with construction and different types of home repair. So that is overall the history of limits.